So hello friends, today I will discuss about introduction to spectroscopy. Okay, so you already know that you already know about electromagnetic wave. Okay, so this is an electromagnetic wave. Okay, so this one, then here two fields exist, electric field and magnetic field. You already know that. Okay, so here electromagnetic wave in here exists in a wave form. Okay, so here energy passes in electromagnetic wave form. Okay, then this is our next slide. Here is a brief introduction to spectroscopy. Okay, so at first an electromagnetic wave come and attack on matter or an object or a particle. Okay, so here these phenomena, that means the interaction between the electromagnetic wave and the particle is called spectroscopy. That means the interaction between this type of radiation and particle, that means this total incident is called spectroscopy. Okay, so for this spectroscopy, what happened? For this attack, there will some changes in this particle or in this object. So here produce some changes. You can see this electron comes here to here. You can see already that. And so after that, here keywords is interaction, electromagnetic radiation and matter. So basically the interaction between the electromagnetic radiation and matter is called spectroscopy. This is very easy thing. Okay, so spectroscopy is the study of interaction of electromagnetic radiation with matter. So next slide, see here. So two things can happen. Okay, so one is absorption. Wait, one slide maybe I miss here. Okay, then two phenomena can happen here. Okay, one is absorption and one is emission. For spectroscopy, two things here happen. Okay, one absorption and one is emission. So first let's talk first about absorption. What is absorption? Absorption is mainly an electron which presents in a matter or a particle when some radiation, that means some electromagnetic waves attack the particle. This electron shift ground state to excited state. Why? Because this electron absorbs the waves, absorbs the radiation, and this electron is now excited. Okay, so for this excitement, electron go ground state to excited state. Okay, that means in this direction. This is the ground state and this is the excited state. So electromagnetic radiation attack the particle and one electron go ground state to excited state. So this total this phenomena is called the absorption. Okay, and next thing is emission. Okay, next thing is emission. Wait. Okay, and what is emission? And emission is the emission is actually the opposite thing of the absorption. You already know that when the electron of the matter comes from the excited state to ground state, that means this direction, that means when the electron release their energy, when electron release the energy which is got from the radiation. Okay, so then for the for this release energy, the electron comes to ground state from the excited state. So electron basically come from excited state to ground state, this direction. Okay, this black, this direction. Okay, so this incident is called emission. So for spectroscopy, two incident can happen, one absorption and one emission. Okay, so this is very easy. Another thing is this one. So basically why we use spectroscopy? Okay, so basically spectroscopy is for the actually when we want to know the intermolecular structure of any molecule. So when we use then we use here spectroscopy. Okay, especially for complex structure, especially for complex molecule, complex organic and inorganic molecule, when we want to know their intermolecular structure, in this case we use spectroscopy. Okay, so what is the advantage of this? What is the advantages of spectroscopy? Okay, so it's less time consuming. Okay, less time consuming and very less time. Okay, and very small amount of sample is required here, very small amount. Okay, and another thing is this, actually the setup is very costly, but it's cost effective only for the long run. Okay, so especially it's cost effective for the long run. So we use spectroscopy. This is the advantage. So note that one important thing, that in both absorption and emission, the energy in both absorption and emission, the energy of electromagnetic radiation absorbed or released is equal to the difference between the energy of the excited and ground state. So basically for both absorption and emission, the energy of electromagnetic radiation absorbed or released, the energy that the radiation absorbed or released is equal to the difference between the energy of the excited state and the ground state. Okay, so the difference between the energy of excited and ground state is equal to the energy of that radiation absorbed or released when the absorption and emission incident happens. Okay, I think you understand. If you are not understand, then please tell the comment box. I think you like the video Please like, share and subscribe. Thank you.